Assalamualaikum. We are from Group 6. Today we like to present Lab 5, simulation for Lab 5. My name is Musfira binti Mokhtar. I will like to present about the task 1. Four-way traffic light system operate with a predefined cycle of signal to control the flow of traffic at an intersection. The system includes traffic light for each direction, typically facing north, south, east and west. The cycle usually begins with one direction getting a green light, allowing vehicle from the direction to proceed, while others are stopped with a red light. The green light is followed by a yellow light as a warning, indicating the upcoming change. Eventually, the green light transitions to red, stopping the flow from the direction and allowing another direction to proceed. This cycle repeats to manage traffic in all directions and maintain order at the intersection.
For the for discussion for task 1, in crafting the PLC SCADA program for the four-way traffic light control system, our team incorporated key components for seamless functionality. The system starts with the start push button, triggering a latching circuit to maintain continuity. Utilizing timers, each traffic light is activated in sequence with appropriate duration to simulate realistic traffic flow. The stop push button helps the sequence, ensuring user control. The SCADA interface visually represents the traffic light state, providing an intuitive display for system monitoring. Overall, the integration of start-stop push button, a latching circuit, timers, and a user-friendly SCADA interface demonstrate a comprehensive approach to emulating a functional traffic light control system. For the conclusion, in conclusion, our PLC SCADA program successfully simulate a four traffic light control system, showcasing a harmonious blend of creativity and knowledge in basic PLC SCADA programming. The incorporate of latching circuit ensures system continuity while timers precisely control the traffic light sequence, contributing to a realistic simulation. The SCADA interface add a visual dimension enhancing user interaction and monitoring. The team uh, the team's collect effort have result in efficient responsive program that effectively mirror the operation of real-world traffic light control system, underscoring the success application of fundamental PLC SCADA programming principle. Now I will pass to the task 2 presenter.
Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Narativa binti Mokhtar and I will be explaining task 2. Task 2 is about PLC SCADA programming for a sorting system. As you can see at the ladder diagram, it consists with the start button, stop button, and the motor conveyor will be 100.00, and the photoelectronic sensor will be 1.00. And the stamping cylinder will be 100.01, consists with a timer, and the inductive sensor will be 1.01, and the capacitive sensor will be 1.02, and the cylinder for the proximity sensor X will be 100.02, and the electromagnetic cylinder Y will be 100.03. Also, there's a counter for the binary counter. Okay. For the CX supervisor, as you can see, when PB start is activate on, the motor conveyor will operate, and if at the station 1, when there's a presence of an object detected at the photoelectric sensor, the conveyor will stop temporarily, and the time for 3 seconds for the stepping process. And then it will run back, and the proximity sensor, if there's a metal object, it will be detected. For the sensor X, it will be detected, and for the sensor Y, if it will detect it with a non-metal object. As you can see, yes. And stop button to stop operation. Okay. For the discussion part, in task 2, we started our project by setting up the PLC central control unit and programming logic for various components, such conveyor belts, sensors, and actuators. Through meticulous programming of the PLC, we define the behavior of the conveyor belts, instructing them to transport items efficiently based on sensor inputs. The sensors strategically placed along the conveyor belts play a pivotal role in detecting the material compositions of objects passing through. Upon receiving signals from the sensors, the PLC executed decisions, activating actuators to divert items into their respective designated containers. This intricate interplay of programming logic and hardware components facilitated the reliable separation of metal and non-metal objects within the sorting system application. The integration of these duties enabled the PLC to execute control logic smoothly. Simultaneously, the usage of Omron's CX supervisor provides a user-friendly interface for monitoring and fine-tuning system parameters, providing adaptability to changing production needs. As we move on forward in the project, this robust foundation in PLC programming and control logic will serve as the cornerstone for implementing more advanced features and optimizing the efficiency of the sorting process.
Assalamualaikum and good morning. My name is Siti Nur Atira binti Samuji, and I will be presenting the ladder diagram for Lab 5, Task 3. This is the ladder diagram for Lab 5, Task 3. The system consists of push button start, push button stop, operation, outlet valve, inlet valve, and 2 tank, which is storage tank and feed tank. The ultrasonic sensor, which is low level and for high level detection. The address for start button is 0.00. The address for stop button is 0.01. The address for outlet valve is 100.01 and inlet valve is 100.02. For the sensors, the low level sensors 1, low level sensor 2 is 0.03 and the high level sensors 2 is 100.03. For high level sensor 1, 100.04 and for low level sensor 1 is 0.02. The storage tank is storage tank. The storage tank and feed tank use increment and decrement to display the water level. That's all from the diagram. Let's move to our next members for CX supervisor. Thank you.
Good morning. My name is Mary Magdalene, and I'm going to present about the CX supervisor. So, as for task 3, firstly, the low level sensor 2 will be on in the initial condition. When we press the start button, the system will be started. So firstly, the feeder tank will be full with liquid and the liquid will be going to the storage tank first. After the storage tank is full, the outlet valve will be opened and all the liquid will be out from there. So when we press stop button, the system will stop. And as for discussion, in designing the PLC SCADA program simulation for the liquid level control system, careful consideration in variable definition is paramount. Employ analog variables for precise representation of liquid levels in storage and feeder tanks, and use digital variables for tracking the status of level switches and valves. Ensure a safe initialization state setting the feeder tank's initial level to low level sensor 2 and initializing switches and valves to default closed positions. Continuous monitoring of level switches and accurate measurements of liquid levels should be implemented with responsiveness to change in switch states. The control logic governing the inlet valve for automated material feeding must account for liquid levels and switch conditions, incorporating safeguards to prevent overflow and depletion. Additionally, integrated logic for the semi-automated outlet valve, allowing manual control by the operator through the SCADA system. That's all from me. And I'm going to pass to my teammate to talk about the conclusion for task 3.
Hi, I'm going to talk about the conclusion for task 3. The system involves a storage tank with higher capacity than the feeder tank, both equipped with 4-level switches for accurate level detection. Automated material feeding control is facilitated by an inlet valve, while a semi-automated outlet valve allows the system operator to adjust material flow as needed. Our simulation considers the initial condition where the system is inactive and the liquid level is at low level LL2 in the feeder tank. Through a truthful combination of logic programming and SCADA interface design, we ensure seamless operation, reliable level monitoring, and user-friendly control. The outcome is a robust PLC SCADA program that effectively manages liquid material storage, supply, and operator control discharge, demonstrating the team's proficiency in addressing complex control system challenges. That's all for the conclusion in task 3. Thank you for this presentation.